to CodeHS. You're going to see a link in chat. This is an attendance link and doesn't collect any information. This is just simply for us to be able to record attendance and send you out a certificate after this workshop. So we are excited that you're here. And we're just going to wait for about another minute or so and just make sure everyone's in the room. If you're having trouble hearing me or clicking the link, please let us know in the chat and we can go ahead and get you some more assistance. Okay, excellent. So yeah, as I said, my name is Linda Hahn. I'm actually a PD specialist here at CodeHS, and I worked as a teacher for about 15 years. I taught with CodeHS for about 5 to 6 years, the last years that I taught. And so I'm really excited to be here with you. I am joined by Joni. She is also a PD specialist. I'll let her introduce herself.
Hey, good afternoon. Well, I almost kind of did that afternoon evening thing together. So good afternoon, you guys. I'm glad you could join us. My name is Joni Neer. I am a PD specialist for CodeHS and excited to get to watch Gary in action today also. So welcome.
All right, so I just threw the link in the chat again, but I'm going to go ahead and introduce Gary Linden. I am so excited for you guys to meet him. I'm going to let him introduce himself, but he is a teacher trainer here with CodeHS, and he is going to be delivering this workshop tonight. So Gary, I'm going to hand it over to you.
All right, well, hopefully I can live up to your expectations. So folks, I'm no different than you. I've learned by different methods over the years, and so I'm just anxious to maybe share some ideas and go from there. So do you want to talk about this at all?
Yeah, so we're gonna throw a link here in the chat. Joni's gonna throw a link for, if you don't have an account, please let us know how we can assist you, but we're going to go ahead and throw this link into the chat for you. You just want to go to codehs.com/sign up. And again, we can, if you need to be verified as a teacher and you haven't been able to get through that process yet, we can do that tonight as well. So just reach out to us either through a direct message or just go ahead and throw in a chat that you need help with creating your teacher account. But if you don't already have an account, this is where you would go.
And so here's what we're going to be talking about today. I'm going to spend most of the time on the Java application for tic-tac-toe. But as I was sharing with them earlier, you know, I've been teaching CSA for quite a few years. And in my previous life before I became a teacher, I spent my whole life in development and with many languages, probably more than I'd like to imagine. And so I've kind of been more akin to Java typically. And so this year, one of the courses I am teaching is a Python-based course. And so I convinced myself to take the time to try to figure out how can I kind of similarly do what I do in tic-tac-toe in Java and do it in Python. So that's what that is. By no means do I even pretend to be a Python expert. I'm not sure I'd even say I'm a Java expert, but it's there for your perusal, just to see if you like it, and you know, anything you want to do with it, you're welcome to. I'm going to just real quick, if you click on the link for the Java code or the Python, you're going to get this little message up here where it normally says save, where you can fork the code, which is simply make it a copy to your own sandbox. By the way, I use this a lot with my students in my regular day-to-day job, where I will create some starter code and then have them fork it. And so it's a nice way to do that. All right. Not sure. Okay, there we go. So what you're going to see is I've tried to lay this out. It's not 100% the same way that I would present it to the students, but I tried to present it into a structure where I didn't just give you the whole thing at one time and then say good luck. So what I've done here is I'm breaking it into different concepts. Now, the first one, which is this starter code for day one, and so I'm going to slide over there, and you can see this. Let me just go to my program. So this is the starter code, and just a couple quick things on it. Obviously, it's Java graphics, but the structure I tend to use is I always have in the main program an instantiation to another object that's kind of the traffic controller. A lot of times I'll call it a runner, but this time I just called it tic-tac-toe. But I don't try to make the main very complicated. It then instantiates this and then takes it and passes it over to the tic-tac-toe object. And in that, we're extending the JPanel and mouse listener, and I'll cover those a little bit more as we go through. Here's the constructor that gets called when we instantiate it. So all it's really doing is adding the Java mouse listener object to this object and making this focusable. That set focusable is just so that when you click on your screen, it knows which one you're talking about when you click. Now, most games that I have the students build, or that we've even talked about on CodeHS sessions like this previously, would typically, they would have motion. And so you would have to use the Java timer. We're not doing that in this one, because with the tic-tac-toe, it's just clicking. It's just mouse clicks. And so we are controlling the sequence now versus a timer. And so this is more of a manual flow of the code versus an automatic timer that's kicking it off every so many milliseconds. So not a lot of code in here. One thing that you're going to see that I tend to do is I always have a section, and this is in paint component, which is the major method that Java uses when we're doing graphics. I always have a first time section in there, because there's always something that you have to kind of do one time, and you got to get things set up, or later on we're going to be instantiating some objects, things of that nature. And so I just use a typical Boolean, and then in here, just put whatever I want to do one time, so that when I call the paint component method, it doesn't do that every single time, because that's not what you want to do. Now, again, some of these things you may well know, and I'll just try not to be too repetitive, but the super command in Java is what erases the screen. So basically, every time through, we erase the screen and then we rebuild it. It happens obviously so quickly that we don't typically notice that. And then most of the time, I am just using 2D graphics in the programs. Now this one, and I'll just hit run, this one was the first starter code, and it just gave them kind of this structure. And then we came down, and I did go ahead and put in the methods for the mouse listener. The mouse listener is an interface, so you have to put in all the methods. You can't just pick and choose. You're required to put them all in, even if it's I would call it a dummy method, just open and close. The only method I have them using right now is mouse pressed. And so that's where we put in our code. And basically, I'm just trying to get them to see that right now there's nothing specific here, but if we click the mouse, you're going to see it's going to print the word mouse pressed, just so they understand a little bit about the mouse event, and then that works. Then we talk about what this does is really get the exact X and Y location of the point where the mouse was clicked. At this point, that's kind of what we did the first day or two of this exercise, was trying to just get them comfortable with the fact that we're using a mouse and trying to click. Then we went to, I'll just go back over here. Then we went to day two, where it was really now learning how to sense within an object. And I'm using rectangles, but it could be any object. But how do you sense where the cursor actually clicked? And so then, then I go to day 2. Now, I do not give them starter code for day 2. They build their code day to day. So now in this one, there's obviously more code, because what they were to do here was, and I'll just hit run real quick so you can see it. They were to build 2 squares, and then we're going to be able to click in one of them, and you can see, hopefully you can see on the output, it says inside of box 1, if I do box 2. The concept was tic-tac-toe is going to be squares. Therefore, we're going to kind of learn, how do I build a square or rectangle? And how do I know that I clicked inside of it? So what you're seeing right here, is we just built 2 rectangles. These are the X and Y's and widths and heights for these 2 rectangles. Then down here in the code, you see 2 draw rectangles and 2 draw strings. The rectangles just drawing the box itself, and then the string, I labeled them so that students could then begin to see which one they were talking about. Otherwise, if they just said it's inside of a box, it didn't make a lot of sense. Yes, I'm using some color commands here. The set stroke is just how thick the line is for the box, and that's what we were using there. Now, the real work after building those 2 boxes was coming down here into the mouse press now, and to get them to begin to understand, how do you do this? Now, in the final product that you have access to, I'm using the rectangle compare intersects function. I didn't want to give that to them. I wanted them to actually mathematically understand what it was. So we went the hard way, if you will. And so basically what this is saying, hey, if the cursor point is greater than the starting, and for rectangles in Java, the start X and start Y is the top left corner. And so starting with the X, which is where the cursor was clicked, just saying, hey, is the cursor greater than start X, meaning is it past this point somewhere? And then, we have to say, well, wait a minute, is it also less than this side, which is the start X plus the width? So we were trying to learn how to do the bounding of where the cursor clicked. And then we did the same thing for the Y. Is the Y coordinate of the cursor greater than the beginning of the rectangle, and is it less than the bottom? If those 4 conditions are true, then we should be in this box. And so that's what we spent a fair amount of time on, trying to understand, that mathematical concept, just so that they could begin to say, oh, I do understand which one I'm in. So that's kind of where that one went. So the next one we went to was actually making the grid. Now, if you've seen mine, when I hit run, you're going to see that it asks how many. I did not do that in the classroom. I did that for me. But I also shared with them how to do it. And when they made the boxes, we implemented making the boxes. But for the rest of it, in terms of testing for wins and things like that, most of them stuck with 3 by 3. Some of the advanced students wanted to do this. What I wanted to show them, though, was when you're writing programs, not to make it so specific that you can't then broaden it for whatever else users may need. So in this case, I'm just going to pick 4, because you get much beyond that, and it's hard for me to play the game. So what I wanted them to understand was, and I'll go to the tic-tac-toe here, and I'm going to come right down into the code where, let me slide this over so it's a little bit more focusable. So there's the scanner that says how many, and then we get the number of boxes. So then what I did was I took the line size, or line size was going to be equal to X max, which is the width of the screen, and divide that by the number of boxes plus one. The plus one was my way of having a buffer around the outside. If I didn't do that, this left side would be right on the edge and the right one would be on the edge. And I just wanted a little bit, and same for the top and the bottom. I wanted a little bit of a buffer so I could use it for messages and things like that. And so that just was, again, a concept of how do you make things that are based upon input from a user versus hard coding it into the program. And so therefore, they didn't have to know what size the lines were going to be. And that was kind of a tricky concept to try to get across, is that you don't want to limit yourself when you're developing, especially games. You want to have it as flexible as you can and not have to then go back and rewrite the whole program when you want to make a change. So that's what this math in here is. Then we used an array, and we just then took the number of boxes, which was the input, and just multiplied it, because obviously it's a square, so whatever the number was is just that many. Now, I'll put a comment in here. We did not use 2D arrays, because this comes out of my intro class, and we don't cover that until the AP class. And so I jury-rigged. If you do 2D arrays, you're going to notice this looks like a 2D array, but then we're just adding it to a single dimension array and manually counting is what we're doing here. And so again, the concept of rows and columns, a nested for loop, and obviously they're both going for the number of boxes, because there's, in this case, 4 and 4. So that was pretty easy. Then we talked about the math of how to come up with for each square. Now, each square, if I just slide this over a little bit, each square object, and I'll go over there in a minute and talk, but each square knows where it is, what it should draw, and whether it should put an X or no, or leave it blank. And so, again, the whole concept of object-oriented programming is to make the square, in this case, as control as much of the logic as it can and not have it all buried into the main program. And so then we went through the math on, okay, how can I come up with a way to figure out, I mean, this all looks like it just was drawn by one thing, but it's each square drawing itself. And so we came up with this concept that just says, hey, we're creating a new square. And we came up with a start X and start Y, which for us, we use 10 and 10 for this first box. And then we just added to it the line size times the column. So column is the inner for loop. And so for the second one, it's the start plus the line size, and then it's start plus the 2 line sizes, and et cetera. And so once we kind of went through that, because again, really wanted to focus on, how do you solve logic problems and not just sit here and say, well, that should be 10 and this should be 100, but to put it more into variables and, try to use algebra and concepts like that. And so that's how we built them. Then here's that end of that first time again. And then we just had a straightforward for loop for however long it was. And again, I really try to emphasize not to use real numbers. And so in this case, whatever the length of the array is what we're going to use. Because if I reran this and made it, 5 wide, well, I don't want to have to come back and change this code. So the only code I'd have to change, well, there would be no code I would have to change actually, because everything is based off from that one concept. And so then it calls the print square routine, and it's passing with it this graphics package right here, the 2D graphics package. So with that said, I'm just going to go over and look at the square for a moment. It's just a pretty simple object, but we've got a rectangle that I'm calling my rectangle. And then we've got some key variables, the starting X, the starting Y, and how long is the line. Now it's easy because it's a square, so we only have to know one side and it works out fine. So the constructor that we just looked at, when it gets called, it's passing the starting X, the starting Y, and how long is the line. So then we associate those to our instant variables that we had defined up here. And then we instantiate the rectangle. And of course, we defined it up here so we can use it in both methods. And so it's just a new rectangle and the start X, start Y, line size, line size. So now every object has that information in it. Now the print square method receives that graphics method, and we just set the color to black, created a stroke of 10 just to make it a little bit thicker. And then we use the draw command for the rectangle. And so if I go back and I'll start it up one more time, and I'll make it 6 this time just to make it interesting. I'm not going to try, well, we aren't yet where we can play the game, but that gets kind of difficult after a while. It's just more fun abstractly to try to figure out how to do this. We did not do anything more in terms of the mouse listener in this one. We just left that alone because that's in the next one. So again, this was a lot of conceptual thinking on how to draw this, how to write the algorithm. I'll go back to that, how to write this algorithm right here. And for them to be able to do that. So we did some things like, let's draw it on the board, or we got some flip charts we use and try to figure out mathematically, how could you come up with an algorithm? And we did that just recently on the winning strategy too. All right, so that was day. And when I say day, some of these took more than one day, so please don't believe that it was in a day. The next one was doing the clicking. And so this one we did add to the mouse listener. And so in this one, it's basically, let me just say 4 this time. This one, we were adding the logic to say, which square did I click in? Now, because this isn't an array, this is going to say square 0. Or this one would say square 6, I believe that it would be 5, I'm sorry. 2, no, 0, yeah, 5, okay. And then this one would be 15. And so we took the information that they did for those 2 simple squares, and now we had to do this through the array. So if I go back over the tic-tac-toe, didn't change anything up front. It's all the same. But when we got to the mouse listener, now we had to do a for loop because, again, with an array, pretty much have to always do a for loop. And so going through the array one at a time, X and Y, again, is where the mouse is pressed. And we use the very same logic that we talked about for, I think it was day 2 or 3, where we were testing within those individual boxes. But now we just had to expand that to use the array. And so now it became my square array and I for the iterator. But now we had to go create some variables over in the square object because we don't know what they are in this object. The first time, if you remember, we created the rectangles in the tic-tac-toe object. And so they easily knew what those were. Well, now, not so much. We had to go back over to the square, and they had to write some methods to return the X and the Y, because we needed to have that so that when we did this testing, that we could make sure which one it was. And so that's what we did on this day. Again, getting them to understand, how do I associate this with what an object is? That's a conceptual leap in object-oriented programming, that each square has its own information. And so some of them are struggling with where that was. All right. Now, For this one, what we did here, and I'll just hit run again. And I'll just do 4 again. So in this one, the object was to now start adding X's and O's to the square. And so you begin to see that we could click and add that. And so this was kind of like when they became really excited, like, oh, wow. Now, if you notice, there's a pattern going on here, is that for this exercise was mostly over in the square object, because we had to figure out how we're going to do this. So we created a variable, we made it an integer and simply just called it X or O. And our thinking was that a 0 represented a blank square, a 1 would represent an X square, and a 2 would represent an O square. And so then we had to add logic into our code that would say, well, wait a minute, if it's X or O equals 1, then we're going to set the color to red. We came up with a creative way to draw the X based on the line size. The reason for that, and I'm not going to spend a lot of time on it, but the reason for that, again, is based on the proportional size depending on how many squares you have in a row. That's why this math is what we came up with. So if it was 5, it becomes smaller, if you will. And so that's what we were doing there. And then X, and then if not X, then if it was O. If it wasn't either of those, it just left it blank. And so again, these get called every time that we click and the screen gets repainted. And I'll go back over to where we click. And there's the repaint command. Now, if I comment that out real quick, and let's just run again. And I'll just do 4 again. And we had a lot of students at this point saying, well, I don't see anything. Nothing's displaying. The reason is we're not telling Java to repaint the screen. And so it's not erasing it. And what you see is what got done that very first time. And so the repaint, then we manually added so that when I run it, then when it comes through this mouse press logic, and then when I say, okay, I clicked, and it hits repaint. It was doing it, but it really wasn't. You know, the clicking was working, and we were changing the values over into the square, but we weren't calling the method in square. We weren't getting into this part right here. And so it was never redrawing it. So that's what that is all about. All right. Oh, I'm sorry. There was one other thing I wanted to just say there real quick. And so after we did that, I didn't want to put too much into this exercise. And so I just had them add a very simple alternating even odd concept, where if it was even, modulus 2, if it was even, we would change the value to 1. And if it was odd, we would change it to 2. So depending on which square the I was clicked, whether it be an X or an O. And so again, we had to go back to the square module, and we had to add some logic to update the X or O value. And the one thing we did though was we said, listen, if it's not a 0, meaning it's blank, you cannot update it. And so if you sat here and tried to click on this one square now, this stops it from updating. It just won't let you update it. And then you can go on and do your next one, and et cetera. So again, we talked about how can we prevent somebody, you know, without that, it lets you just change it all the time, which isn't really the way the game should be played. So we went through conceptually, how do you do that? How do you make a determination? And, you know, again, I would always tell them, there's probably 20 ways you can do these things. You know, you're stuck with my perspective, my baggage, my way of doing things. It sure doesn't make it right, but that's kind of what we did here. All right, so the next one then was kind of, you know, several days rolled up together and just doing all the different wing combinations. And this one, I'm switching over to my full version. And so it gets a little bit bigger, obviously. And so let me just kind of get back up to the top here real quick. And this is in the tic-tac-toe. And so, and I've got a lot of comments in this version. Hopefully that's helpful. There's nothing different in terms of the determining the squares and all that. I did add a little bit of different logic for putting the buffer around, not worth the discussion. The way I did it in the other one with just adding 1 to the number of squares worked just as fine. And we created the squares. All right, now here, well, let me go back up because I imported random up here and I created a random method right here. So in first time, before we start the game, we created a random Boolean, and turn was a Boolean variable. And I know it doesn't sound like, how can Boolean be very random? Does it need to be true or false? But we don't know what it's going to be because, you know, we didn't want the game to always start with X or always start with O. So we just made it random Boolean. Again, they gave them a chance to understand how does that work. We've done random for colors, which are integers, but this is the first time we did a random Boolean. Now, I'm not going to try to take you through every little piece of it, but there is a Boolean variable that I turn on if there's a winner. And so what that then does is create the next game, who starts type thing. So that's what's going on right here. And it sets all the squares back to 0. So it's like the start over concept, if you will. Then we paint the squares like we did before. And then I call a method check for winner, and we'll go there in a minute. But if it's true, then we kind of go through some things here where I say, well, I don't know if you notice at the bottom of the screen, let me try to get it back up here. I tried to build into this that you didn't have to restart it every time. So I'm just going to say 3 this time. And so if we had a winner, you notice down here at the bottom, it says to restart the game, click anywhere in the tic-tac-toe square. And so you could just click here and it'll start over. And I just did that so that you could, you know, have multiple plays type thing. So that's what's going on right here. Okay. Now, here it's saying, hey, is it turn? Now, again, in this module is where we're keeping track of the turns, and turn is set to true or false. True being X and false being O. And so that's how we're doing all this alternating of the play. And if I say X and Y, please forgive me. You don't know how many times I have said that in my class, and I even have written some of the code to say X and Y. We're just so ingrained to say X and Y. So if I say Y, I really mean O. So this is saying, hey, is it a turn? Whose turn? X. And there's not a winner. And so that's where, let me just start over. So that's where this is coming from right there. It's just saying, well, display whose turn it is then. If it's X's, do it in red. If it's O, then do it in blue. So that's all that's accomplishing there. Now, we'll come back to that in a minute. I've got methods, these methods, I'll just say what they are and I'll come back to them. This is the method to display the horizontal winner. I have never figured out how I can combine horizontal, vertical, and crisscross into one. My brain hasn't gotten there yet. So that's for the horizontal, this is for the vertical, and then this is checking for the squares to see if I have a winner. So again, this is where we start going through here. And again, based on time, I won't take you through all of it, but basically, for the horizontal, I do a row column check. And what I am essentially doing is as each row starts, we're setting this variable all same back to 0, and I'm capturing the first square. So in this case, temp would have 0 in it. I'm sorry, O in it, which would be a 2. And so temp would be a 2. So now and this is for the horizontal, so let me just kind of try to do this correctly. So when I put this one there, so what this is doing, it's saying, going through all the columns in that row and saying, is it equal to temp? If it is, add. So when you get done, in this case, if there's 3, that's what this is doing right here. If there's 3, then you have a winner. And then it calls that method that we skipped over to print the winner and to draw the line. Okay, so that's what this is really doing. The only other little ingredient right here is, like if you don't add this and temp's not equal to 0, every row is going to look like a winner until you start putting things in. So that's just a way to keep the blank rows from showing up. And for the vertical, it's almost identical. The only thing that you're going to see different is I reverse the for loop. We're doing column first and then row. So conceptually, it's the same logic. It's just going in a different order so that as you come down, it's testing down through each row. And so it's same logical concept. And then we get the crisscross. And this is where some mathematics kind of had to play in, because I couldn't just, these I could base on how many squares there are. Coming down across is a little bit more challenging. And so there's a little bit of math here that just says, I'm just doing, in this case, row, and going through and basically trying to find each of the squares for each of the rows based on that. And so it's just what row am I on times the number of squares and times number of squares plus what row I'm on. Mathematically gets you to the individual item that you need. And so that's for, I believe this was for left to right. And then the other one, and in this one, we print the winning stuff right here. And then the other one is the right to left. And it's just the reverse logic. So instead of, you have to add column times row. So I'm not going to try to make this into a math course, but that was the algorithm that we used so that we could then do that. So if we go back up to where we printed for the horizontal, see vertical, they're both the same, but this is the horizontal. So when it calls, it gets the graphics package and it says, what is the index number in this array? So in this case, there's 0 through 8. And so that would be representing which one of these is the first. So let's go back and do a horizontal real quick. I could have just hit new, but so what this is asking for is which square is the first square in the row. Because if I have that information, I know how to draw this line. And so this is saying, what is the element number, the index of the first element in the row that won? And then we go through this and I go through and say, hey, if it's 1, meaning is it X, then set the color to red. If it's O, set the color to blue. So what's going to happen then is it's setting the color for this winner statement up here. So then we come in, we set the font. Here's where we type the winner, and we get the character, X or O. And then we set the color green. And the draw line for horizontal and vertical is reasonably easy. We start, I call it anchor X, that's my start X. So give me the start X for this first box for the X location. For the Y location, again, remember it's right up here for X and Y. I wanted the line in the middle, so that's why you see this plus the line size divided by 2. I'm just trying to push the Y location down halfway through the box. And then for the X location here at the end, all I said was, well, add it to the starting X and just take the number, the line size, and just multiply how many squares we have. And that will give me this X location over here. And so again, that all kind of goes back into the concept of having kind of relational programming that's not dependent upon any specific fixed algorithms. I won't bore you going through the vertical. It's kind of the same concept. Let me just see if there was, and yes, this is where I got that X or Y character. It's just a matter of returning a character if it's a 1 or a 2. Okay. All right. I think I was trying to end by 4:45 and I'm awful close. So with that said, I'm going to stop and leave the rest of the time for Q&A or other ideas. So Linda, or do you want to jump in?
Yeah. So thank you so much, Gary, because I personally have never really worked with the arrays with the rows. That was fascinating to me. I'm sitting over here. I know you're in the tic-tac-toe game, but I'm in the square, just kind of amazed just by the square part. So, but are there any questions that we can answer? I think I've thrown in the full slides into the chat. So if you didn't get those, that link, let me know. I can throw it out there again, just so that you have all of those redirects. But are there any questions that Gary can answer for you? And feel free, either throw it into the chat, or you can also just unmute. We have a pretty big group, but feel free to unmute, and we'd love to answer any questions that you have. And Joni's thrown the slides into the chat as well. So if you need the links to get to the different phases. So as Gary said, this can be in a particular class period, or you can just kind of go step by step with your students. It's really great to be able to see the phases of that game development. So that's great. We're going to be throwing a couple more links into the chat here. We do have some upcoming workshops, so I wanted to make sure to point those out. If you love the workshops here at CodeHS, especially with our teacher trainers who are just bring a wealth of knowledge to the table, because they are right there with you every day teaching. I would love for you to join us again. We have another workshop actually on Wednesday with Portia on P5JS. We also will throw a workshop survey there into the chat in just a moment, but we wanted to give you guys the opportunity. Now, as we said, Gary ended a little early, specifically if you had any questions, so feel free to hop in, and we want to get those questions answered for you.
Gary, I'm going to throw out a question to you. Do you usually give this type of an assignment to your students before they take the AP exam, like after they've learned all the concepts before, or do you use this? It looks like a great project to do even after the exam, after they've taken it, but yet to challenge them some more too. So how have you implemented it into your classroom?
Sure. Actually, I do this in the introduction course because, as you know, the AP exam doesn't really cover graphics too much at all. And so this is, our intro course is intended to try to get students interested in programming. So as you can well imagine, a lot of this stuff is stuff that I give them and help them implement. And then we try to reiterate it and go back and forth. I have kind of changed my approach to the intro course in that I pretty much just do games from the beginning. We start off with a simple Pong game, and then we move to we did a space race game, then we did a break brick wall game, and now this one, and then we're going to move into the snake game, and then they will make their own game during fourth quarter. So I know looking at this, you would say this is way too complicated for an intro class. I agree, except I want them to kind of struggle through it and begin to get the concepts down, and they all like playing games. And so that's why I've done this approach. For the AP class, to answer your question, what I plan or have done and plan to do is I'm going to go into the Python game after the exam, because they all want to know, when are we going to talk about Python? And so we're going to cover that then after the exam.
Great. Thank you, Gary.
Mm-hmm. The Python game isn't nearly as robust as the Java game, just because I don't know Python as well, maybe. But if you notice, to start this game, I wanted to make sure I understood how to do mouse handling. And so I said, you got to right click to start the game. And then, you know, it's just kind of doing the same concept. This time I made the line diagonal, but again, it's using a lot of the same concepts that I would use in Java in terms of using lists, which are basically an array. And so you kind of, as you go through here, the nice thing is Python does allow you to have some ways to get to some of the variables a little bit easier than you would in Java. So you're more than welcome to just play with that and have fun. Again, it was just you know, an off project for me to make sure I understood it so that I can teach it when we get there after the exam this year.
Great.
We have a couple questions, yeah, in the chat. Go ahead, Joni.
No, you go ahead. Take it with Gary.
So Drew just had a question. Do most of your students use Java, or do you recommend one language over another?
Well, I'm limited by what our county says, I guess. You know, the AP CSA, obviously, it has to be Java. And so they have always stuck with Java to be in the intro course as well. There is a Python course, or Python's learning. We just introduced the CSP course, the Computer Science Principles, and that's a combination between Python and JavaScript. But you know, it's all Java.
Yeah, Gary, also, thank you. Tim shared out a couple of things, of ways that he has done that game also. So Gary, I'll let you take a look if you are into chat. And if not, those of you who are with us, take a look, because he's got some really great ideas, additional ideas of how to take care of the winning part of how to set it up and take care of the winning part. And so, Gary, if you have any additional comments for Tim there, with you kind of using an array to hold the state of each one of the blocks to be able to tell whether they have a winner or not, because the sum is going to equal 3 or 30. I guess it would probably be, right? Yeah, so if the total is 30, then yeah, so that's really cool. So you guys, those of you who are with us,
Right.
make sure you read through Tim's comments there in the chat.
Absolutely. Absolutely. Yeah, that's what I said. And Tim, you bring up a very good point is there are many ways to do this. Because of my interest in object oriented, that's why I kind of pushed the way I did to have the array of objects so that they could begin to understand how that concept works. But what you're saying makes a whole lot of sense.
Any other questions, you guys? Again, you can go to chat, or we've got a small group here. We've got like 25 people or so here. So if you've got a question or comment or want to add in some ideas, please just unmute yourself and pop in on chatting with us here.
I'm also going to go ahead and throw into chat the attendance link again. I know if you were here with us at the beginning, that link will just help you to be able to get credit for today's session. You'll be sent this certificate that will include the PD hours, and you can definitely yeah, there we go. Joni has put it into chat, and I have too. But what you will be receiving again is a certificate for attending today. And then if you don't mind, I also put into chat a survey, a workshop survey for today. We'd love to get your feedback. So if there are no other questions, but I just want to say thank you so much to Gary for taking the time to just not only share this with us, but also challenge each of us to. I am definitely new to Java, so watching you work through particularly arrays was really helpful. Are there any questions for Gary, though, in regards to anything having to do with teaching Java? I got a quiet group here tonight. All right. Well, thank you so much for joining us. And thank you, Gary, for this amazing session. I am so excited also to dig in. I know Python a little bit better, so I'm going to play around with that a little bit later. But if you have any questions, of course, reach out to myself, Joni, or Lori, who you should have received the registration link from today. And we love hearing from teachers. Again, if you fill out that workshop survey, let us know how we can serve you. And yeah, as Joni said, if you want to join us on Wednesday, we have a P5JS workshop as well. And thank you so much for joining us tonight.
Thank you, folks. I really appreciate your time.
Thank you, Gary.
Thank you.
Good night.